Hi Year 11, this is our last lesson for the topic of arithmetic and algebra. So this is what we've learnt. We've looked at arithmetic in particular absolute value. We've revised algebraic techniques including expanding, factorising and algebraic fractions. Then we learnt about surds and indices and in particular rationalising the denominator. And then last lesson we looked at solving equations. Linear equations, quadratic equations, inequations, absolute value equations and literal equations. So this last lesson is on systems of equations, which are also known as simultaneous equations, which you should be very familiar with. There are three methods for solving simultaneous equations. There's a graphical method, and then there are two algebraic methods, the elimination method and the substitution method. I'm going to start with the graphical method because it illustrates what's actually going on. The equations y equals 2x minus 3 and y equals x minus 4 are both straight lines. And if we graph them, we can find a common point. Now, just quickly, I'm just going to graph them using a table of values. So there's y equals 2x minus 3 and y equals x minus 4, that table of values. I'm plotting the points and drawing them up. We can see that the point of intersection is -1, -5. And that's actually the solution to the simultaneous equations. Now let's look at the algebraic methods, and as I said, there are two methods, the elimination method and the substitution method. Now with the elimination method, you'll often see the equations are set up like this. An x part and a y part equals a number. And that's so that we can sit them underneath one another and line them up. Now we're looking to see whether there's something there that we can eliminate. And we can eliminate these x's. Okay, this is 1x and 1x. And if I subtract equation 2 from equation 1, I'm going to get rid of that x. So x take away x is 0. 2y take away -y. Now be careful here. 2y take away -y is 2y plus y. That's equal to 3y. And then 7 take away -5. Again, 7 plus 5 is 12. So we've eliminated the x. Now let's solve for y. Divide both sides by 3. Y is equal to 4. And don't stop there. We've only found part of the answer. We've only found what y is equal to. We need to substitute this back into one of these equations to work out what x is. Doesn't matter which one we go into. So substituting into equation 1, I've got x plus 2 lots of 4 is equal to 7. So x plus 8 equals 7. X is equal to -1. So the solution is x is equal to -1, y is equal to 4. Now that was a fairly straightforward one, but sometimes we have to multiply one or both of the equations to be able to eliminate a variable. Like this example, we've got 2x plus y equals 4 and 3x plus 4y is equal to 1. We can see that the x's have different coefficients and the y's have different coefficients. So I need to multiply one of those by some number to make either x or y match. And I imagine the easiest way to do this is to multiply this first equation by 4, because that'll give me 4y. So we've got 8x plus 4y equals 16, and then the second equation goes underneath. And again, I've got 4y and 4y. Whenever the signs are the same, I need to subtract. So 4y take away 4y. 8x take 3x is 5x. 16 take 1 is 15. And then divide both sides by 5, x is equal to 3. Don't stop there. We've only got half of the solution. Substitute the 3 back into one of these. I'm going to substitute into equation 1. So 2 lots of 3 plus y is equal to 4. 6 plus y equals 4. So y is equal to -2. And so the solution is x is equal to 3, y is equal to -2. Now let's look at the substitution method. To substitute, we change one of the equations to make either x or y the subject. Now it's possible that it already is. Then we substitute it into the other one. So here's an example. Solve x plus 2y equals 7 and x minus y is equal to -5. Now there's numerous ways to do this. I could make x the subject here. I could make y the subject here. I could make x the subject here or y the subject here. I'm just going to go with the first one. Change the first equation to make x the subject. Now we just learnt this last lesson. Do you remember? So this positive 2y or plus 2y is coming over as a negative. So x is equal to 7, take away 2y. Now all I do is substitute that 7 minus 2y into where x is. And don't forget your brackets. Now tidying up that left-hand side. In this particular instance, the brackets weren't important, but as a general rule, put them in. 7 take away 2y, take away y is 7 take away 3y. Now let's take the 7 over the other side, becomes minus 7. So I've got minus 3y is equal to minus 12. And then finally, dividing both sides by negative 3. So crossing that out and dividing by negative 3, y is equal to 4. Again, we've only got half of the answer, so we need to substitute that y equals 4 back into one of the equations. Now, one of the good things about the substitution method is that you've already gone to the trouble of making the other variable the subject. So don't substitute the y equals 4 into one of these, substitute it into here. So x is equal to 7, take away 2 lots of 4, which is negative 1. Let's look at another example. Solve the following system of equations. Y equals 2x plus 14, 3x take away 2y is equal to 11. Now you'll see the different notation, and also it says system of equations. It still means the same thing. They're simultaneous equations. Now this one's really set up for substitution because I've got y is the subject of one of them. So I'm actually going to substitute equation 1 into equation 2, and this time my brackets are going to be very important. Right, expanding those brackets, I get 3x take away 4x take away 28 equals 11. Tidying that up, this is negative x. We take the 28 over the other side at the same time. So negative x is equal to 39. Now let's multiply both sides by negative 1. We'll pick up the negative and put it on the other side. X is equal to negative 39. Now because we're using the substitution method, we have one of the equations with the other variable as the subject. So I'm just going to substitute x is equal to negative 39 into that one. So y is equal to 2 lots of negative 39 plus 14 equals negative 64. So our solution is x is equal to negative 39, y is equal to negative 64. Now, as a general rule, solutions to systems of equations, particularly in exams, will be integers, but those numbers seem rather large. So what we can do is check it. I can substitute this solution into this other equation and see if it satisfies it. So 3 lots of negative 39 take away 2 lots of negative 64 is negative 117 plus 128, which is 11. So yes, this is the correct solution. Now the substitution method is particularly useful for nonlinear equations. In fact, we would struggle to use the elimination method. Solve 2x take away y, take away 1 is equal to 0, and y equals x squared, take away 1 simultaneously. Now, you should remember enough to realize that we have a parabola here, a quadratic, and a straight line. So we could be looking at two solutions. I'm going to substitute the x squared take away 1 in where the y is. And this time, those brackets are going to be really important. All right, let's tidy this up. We've got 2x take away x squared plus 1 minus 1 equals 0, which gives us 2x take away x squared is equal to 0. Factorize x outside of 2 minus x equals 0 and solve. Either x is equal to 0 or x is equal to 2. So two solutions. Now we need to find the solutions for y. So I'm going to substitute the 0 into here. Y is equal to 1. We can write it as a point. So 0, negative 1. And now substitute the 2 in. And that gives me 3. And as the point, it would be 2, 3. So which method do you choose? Well, the graphical method is inaccurate, particularly if you have non-integer solutions, and it's cumbersome. So you'd really only choose that if the graphs were already drawn for you. The elimination method works nicely when both equations are of the form ax plus by is equal to c. And the substitution method is the only choice for nonlinear equations. Okay, let's move on to systems of equations with 3 unknowns. If our equation has 3 unknowns, we need 3 different equations to solve it. Now remember, graphically, when we're solving a system of equations with 2 unknowns, we're looking at the point of intersection on a 2D graph. With 3 unknowns, we have a 3D axis. We've got an x-axis, a y-axis, and a z-axis, and we're looking at the intersection point of 3 planes. Let's start with a puzzle. Now, this particular problem I usually give to either Year 9 or Year 10, and there are lots of ways to do it, including guess and check. But it is a really good example of 3 equations in 3 unknowns. Sam, Elliot, and Jeremy noticed the following facts about their ages. The sum of Sam and Elliot's ages is 9 more than Jeremy's age. Twice Jeremy's age less Elliot's age is 5 more than Sam's age. And Jeremy's age less Sam's age is 1/4 of Elliot's age. How old are the boys? So we would start this question by defining some variables. We would say let S be Sam's age, let E be Elliot's age, and let J be Jeremy's age. Let's look at this first one. The sum of Sam's and Elliot's ages is 9 more than Jeremy's age. The second one, twice Jeremy's age less Elliot's age is 5 more than Sam's age. And the last one, Jeremy's age less Sam's age is 1/4 of Elliot's age. So here are the 3 equations. Now we can go through and just eliminate one variable, get back to 2 equations in 2 unknowns, and then solve them simultaneously. And I'm going to show you how to use that method in the next question. But if we can eliminate 2 variables, then that's much better. So I can see this j minus s sitting here, and I can see that I can easily make that from the top one as well, j minus s, just by moving that s over and then moving the 9 over this side. So rewriting the first equation, I've got j minus s equals e minus 9. Now, if j minus s is equal to e on 4, and j minus s is also equal to e minus 9, then e on 4 must equal e minus 9. And now we have an equation in one unknown. So multiplying both sides by 4, I get 4e take away 36 is equal to e. Taking the e over this side gives me 3e take away 36 is equal to 0. And when I solve it, I get e is equal to 12. So Elliot is 12 years old. Now I'm going to substitute e equals 12 back into these 2 equations. So j minus s equals 12 take 9, which is 3. I'm putting the 12 in here. 2j take away 12 is equal to s plus 5. Now I could spend some time tidying this all up and then doing the method of elimination, but I'm actually just going to do substitution. I'm going to make j the subject and then substitute s plus 3 in where j is. Don't forget your brackets. Now when we tidy all of that up, I get 2s plus 6 take 12 equals s plus 5. Giving me 2s take away 6 is equal to s plus 5. Taking the s over the other side and the minus 6 over this side, s is equal to 11. Now remember that we had changed one of those equations around. We had j as the subject, so I'm just going to substitute the 11 in there. And so j is equal to 14. So Elliot is 12, Sam is 11, and Jeremy is 14. Let's try one more example. Solve for x, y, and z. X take away y plus z is equal to 7. X plus 2y take away z is equal to negative 4. 3x take away y take away z is equal to 3. Now it can be a good idea to actually label your equations. Here's my top tip. Study the question carefully to find one variable that can be eliminated. Now in this case we're looking for a variable that will have the same size coefficient. It doesn't matter if they're pluses or minuses. Can you see that that's the z? Now through various combinations we'll be able to find 2 equations where the z has been eliminated, and we will reduce our system of equations down to 2 equations in 2 unknowns, which we know how to do. Now I always try and look for differing signs because that way I can add the equations together, which is easier. So if I add 1 and 2, I'm going to eliminate the z, and if I add 1 and 3, I'm also going to eliminate the z. So adding equation 1 and equation 2, I get 2x plus y is equal to 3. Adding equation 1 and 3, I get 4x take away 2y is equal to 10. and I can easily divide every term here by 2 and simplify it. So now we have equation 4 and 5, which we are going to solve simultaneously. And again, I've got differing signs there with the y's, so I'm going to add these two together. And that's going to give me 4x is equal to 8. Divide both sides by 4, x is equal to 2. So I have my first bit of information. Now I'm going to substitute this x equals 2 back into one of these. I'm actually going to put it into equation 4 to work out what y is equal to. So 2 lots of 2 is 4 plus y is equal to 3. Y is equal to -1. Now don't stop until you have the value of all the variables. We've only got x equals 2 and y equals -1. We don't have z. Now we're going to substitute both of those back into 1 and figure out what z is. Be careful with these negatives. 2 take away -1, so that's 2 plus 1, which is 3, plus z is equal to 7, so z is equal to 4. So the solution is x is equal to 2, y is equal to -1, z is equal to 4. Okay, that's it for the topic. Now the next topic is functions and relations.